Okay, Dragons, today's lesson is on exponents. Here, a little basics first. We got to do a little review, make sure we understand everything. When we're talking about exponents, it's a shortcut for multiplication. We are multiplying, repeated multiplication of the same number. So in this particular case, we have 5 raised to the third power. So the 5, the number that is being repeatedly multiplied, is called the base. The 3 is the exponent. It tells me how many times I'm going to multiply the base. And collectively, the 5 base, the 3 exponent can be called a power. Okay, so what does this mean? Again, the base is the number that is repeatedly multiplied. Notice the multiplication dots. You don't see plus signs, you don't see minus signs. You see multiplication, and that's going to give me 125. Calculator does a quick check on that. Okay, so remember, every number has an exponent. If you don't see it, it's 1. Okay, so if we look over here, this is 4. How many of them I have? I have 1 of them. The exponent of 1 is there. I have 1 negative 3. Exponent of 1. If you don't see it, they're 1s. In variable bases, they are assumed not to be 0, and you'll find that out why later. But again, what's the exponent on this guy? I have 1 variable a, so that exponent is an understood 1. We're going to need that later on, so remember that, okay? Alright, I'm going to give you the rules real fast, and then we're going to come back and we're going to talk about it. Rule number 1, you multiply like bases. You're going to write the base once, and you're going to add the exponent. So again, we have 5 squared times 5 to the 4th. We're multiplying like bases. So my rule number 1 says I'll write down the base of 5, and I'll add the exponents. Now there are more explanations to this. You can see more detail. Look at the posters in my room. Right now I'm just giving you the rules, the meat and potatoes of it. And just what we have right here is 5 to the 6th power. Alright, the common base is negative 1/5. I write it down one time. Again, they are being multiplied. These rules happen if the bases are being multiplied. And they are. It's multiplication dot. So we write down the base. We don't make any changes. And my rule says that we take the exponents and we add them. So my answer is negative 1/5 raised to the 13th power. Over here, we're multiplying like bases. Oh, hey, what's that exponent right there? Every number has an exponent. That's right, it's a 1. So I'm going to put that in there because when I write my base one time, I'm going to add the exponents. This problem gets a lot of students because they just write down 6 to the 10th. This right here is 6 to the 10th, and I have one more. So that means that I have 11 factors of 6 to the 11th power. And when you start getting into variables, these parentheses are just grouping, but if you look at this problem, it's still straight multiplication. This is 5 times a to the 7th times 4 times a to the 2nd. So what I want you to do is I want you to separate, put the numbers next to each other. Notice I took the 5 times 4. Oh, hey, we know what that is. That's going to be 20. Okay, and then we're going to take the like bases of a, and we're going to put them next. Now, what are we doing with these like bases of a? Oh, hey, we're multiplying these together. They're squished together. So we're going to add the exponents on the base of a. So again, 5 times 4, we learned that in elementary school, that's 20. And now we're multiplying like bases. The rule says to write the base once and to add the exponents. Final answer is 20a to the 9th. Okay, so again, don't let these problems throw you off. It starts looking like alphabet soup. Take it a little bit of time, separate them up. You have this c, oh, what's the exponent on c? That's right, there's c to the 1st, times, what's the other c? C to the 3rd. And then put your d's together. I like to go alphabetical. You see, it's just straight multiplication. These parentheses are grouping, but it's also multiplication. So after we rearrange it the way we want to, we really don't need the parentheses. Rule number 1 says that if you multiply like bases, like we are with the c's, you write the base once. you add the exponents. 1 plus 3 is 4. Do the same thing over here. D, write it down once. 2 plus 2 is also 4. That's it. Final answer. Exponent rule number 2. If you divide like bases, we're going to write the base once, and we're going to subtract the exponents. Okay, so let's look at some examples here. We got 6 to the 5th divided by 6 to the 4th. Okay, the fraction bar is your division. So again, if you divide like bases, which we are, we have a like base of 6. We're going to write the base of 6 once, and we're going to subtract the exponents. Now make sure that you subtract your exponents from top to bottom. Okay, it's a bad M, but you will get over it. 5 is my top exponent. I'll subtract the bottom one, and we get 6 to the 1st, which we just know is a single 6. Okay, and when we start getting into variable problems, same thing. If we have x to the 4th divided by x to the 2nd, we have a common base of x. We'll write it down once, and we'll subtract our exponents from top to bottom. Final answer, x to the 2nd. All right, if they start combining things on us, we're not going to freak out. We're just going to separate them. So if I look at this alphabet soup fraction here, I'm going to say, okay, well, I can make a fraction out of the a's. That's a to the 3rd over a to the, what's that exponent? Don't see it. Oh, it's a 1. Put it there. Multiplied by b to the 5th over b to the 2nd. You see how I just split these up? Okay, so now individually these problems right here look like the one we just finished, and we're going to do them the same way. So focusing on the base of a, we'll write it down one time. We'll subtract the exponents from top to bottom. 3 minus 1 is 2 on the base of a. We'll go to the base of b. It's being multiplied, so we'll just squish it right next to the base of a and subtract our exponents from top to bottom. 5 minus 2 is 3. There's your final answer. Okay, so again, don't be intimidated by problems like this, and they can seem pretty hairy when you look at it. I'll give you one like I'm talking about. You notice up here we have 32x to the 3rd, y squared, z to the 5th, all divided by 8x, y, z to the 2nd. Okay, and again, that can be intimidating, but if we just come over here and we separate the numbers, we can divide 32 by negative 8. We can make a fraction with my x's, make their own little thing. We can make a fraction with the y's. We can make a fraction with the z's. Just separate them out, take them individually, and use your rules, and you'll be just fine. So as we take a look at this, 32 divided by negative 8 is going to be a negative 4. Over here we're dividing like bases. Remember that x is to the 1st. What we're going to do is we're going to subtract our exponents. 3 minus 1 is 2. And again with that y right there, that has an understood 1. We'll write the base once, subtract the exponents. 2 minus 1 is 1. We can write it or we can just leave it. Remember, if we don't see an exponent, it's a 1, so I'm going to leave it. And finally, on my base of z, this will put us to sleep, right? This is going to be 5 minus 2. It's going to give me an exponent of 3. So this problem didn't really, when you take them individually, it's not that bad. Okay? I'm going to stop it right here because I'm at minute 9. I'll go to part 2.